Unify, I already mentioned it. That's the tool which helps us to make our Rust library available for other languages. And basically, yeah. So just have a look at the documentation, because it's pretty good, and I thought that makes sense to make slides out of this. So if we open again, it's the tool is from Mozilla, so that's why it's on mozilla.github.io. But you see the format is like the Rust book, right? The layout, the template. So it's also another good thing is Rust projects tend to use this layout, and you open a documentation and you see you're familiar with it. For example, if you press S, you can search. So you know this, you learn this shortcut once, and you can use it. Okay, Unify. What is it? So it's a tool which automatically generates language bindings, targeting Rust libraries. So what's the problem? The problem is that Rust is a compiled language. So when we compile it a binary, Rust compiler allows us to do what's called cross-compilation. So we can compile, let's say, on Linux, x64 to IRM or to something else. That's nice. But as a result, we get a binary. And it has a foreign function interface, which is like low level. It's hard to use. And if you use Python or Swift for iOS or Kotlin for Android, then it's hard to use them directly. You need to write some code to kind of make it simple. And the thing is that every library developer, Rust library developer, faces this problem. So the idea is, can we solve it once for everyone? So that's the idea of this tool, which would generate automatically these language bindings for you. So you don't need to write Kotlin or Swift or anything. It will generate it for you. And then a consumer of your library, let's say it's iOS developer, and they have no clue about Rust, but they know about your awesome project. They can take your library, and you was kind to generate a Swift package for them, and Unify will generate bindings, and the user of this library will just see Swift code, Swift methods, Swift interfaces, and they will be able to use it. So very convenient. Yeah, so that's the idea. Yeah, they say that they would not help you to ship a Rust library to this platform. Unfortunately, so you need to, because it's kind of very language specific. If it's Swift, it's a Swift package. They use their platform to distribute packages. If it's Android or Java, you can use, or Kotlin, you can use Jetpack. We use Jetpack for that. But still, it's a leap forward. So what's the design? Since it's Mozilla, they said like Firefox desktop, probably the browser, Firefox for Android, Firefox iOS. Never mind. So what's the idea? The idea is that you have, you defined a file. So you have your library, and you define a file with your interface definition file. Then you put your library and this interface definition into this tool, Unify bin.gen, bindings generator, and it will generate for platforms you asked. It will generate you. Sorry, they pointed like this, a bit confusing. So yeah, you have. Oh, okay, it's a runtime view. Sorry, it's a runtime view. That's why it's so confusing. Okay, it's not a kind of deployment diagram. So then how we, the kind of deployment diagram would be that I have my library, I write interface definition for that, I feed it to the tool, and the tool will return me language binding. So basically generate code on Swift, in Python, or whatever language I asked, and then I can supply it to the consumer of the libraries. And the consumer of the library, they will yeah, like Firefox desktop, let's say they have, like Firefox for Android, it's more understandable. They will have Kotlin bindings, so it's a Kotlin language, right? They will see the Kotlin objects, methods, so very native for them. But inside, they will be using Rust scaffolding, which is also generated for you, so we don't need to care. Some Rust code in order to call your Rust code. And at the end, your Rust business logic. So you can write your logic purely in Rust. So you think about only Rust types. Yeah, with some limitations we'll talk about later. You just need to define once the interface you are about to expose. And then the tool will do this. Okay. Yeah, the supported languages are Kotlin, Swift, Python, Ruby, and there are third-party support for other languages. So it's clear for now what's the tool about, like in general. Okay, then let's see at this, what is this UDL? The UDL file. So the UDL stands for unified unified. Doesn't say this. Unified definition language, something like this. So yeah, you need to express in this file what the interface you're exposing, and you cannot just write anything. It actually should match to the library you provide, to your Rust library. But you need to write it by hand, unfortunately, for now. So it looks like this. It can have free functions. They have to be in a namespace, like translate. You can define dictionaries, which kind of structs. You can define interfaces, which is like in Java, let's say, interface. So you have an object and an interface for this, but you don't know what the object is exactly behind, and methods. So let's have a look individually. Namespace, yeah, you have to have at least one namespace where you can put just functions, taking values and returning values. Yeah. Shortcut doesn't work. I should see. Next page. Weird. Okay. Too many operators here. So there are built-in types, and they, of course, there are corresponding types in Rust. So you can translate your Rust types to UDL types. Yeah, that's what types they support to translate. Quite logical, like Boolean, U8, U32, and so on. Float points, string, vector, time, duration also. References, so sometimes useful. Option, so if your function returns an option, the syntax is a bit different here, like T question mark, so it's kind of questionable, but it's kind of native for Rust, right? The same for result. It's available, yeah. See error sections. They model very nicely errors. So if your function returns a result, it's you can translate it into UDL file. Yeah, some other things like vector, hashmap, and MTNR. What's called unit type, unit. Yeah, also enumerations, and like a simple one, like a num, just right with values, they'll be translated like this, but also a complex one when we have some values inside, like for example IP address, v4 or v6. The syntax is a bit weird here. You define an interface with a kind of attribute or something, a num. But the point here, you can provide, you can kind of match. So, and you can, as a result, you can expose non-trivial enums, which is very helpful. Next, structs. Yeah, if you have a struct in Rust, it will be a dictionary. pretty much one-to-one. Well, the type definition is opposite, right? In Rust, we name the variable and then the type. So interface. Yeah, interface. They kind of showed. They better show it here. The ideal file. Yeah, the interface. When I have defined a struct in Rust and I implemented some methods on this, I can expose them as an interface. And yeah, in the Kotlin, it would be a class with methods on it. Yeah, with constructor methods are like functions. Quite obvious. Definition is functions. Optional arguments, default values, some details. Yeah, errors. That's pretty powerful. It's so for Rust, it can be like set its yeah, this function. Let's say so it's native for Rust. You don't need to think about, let's say, UDL, that you want to expose in UDL when you're designing your library. You can design it as a proper Rust library with which returns results with your error types, so people can consume it as a Rust library. But you can also translate into UDL, and that would be syntax is like this. It would you say throws, and you specify what error it throws, and the error should be error enum, like this. Well, it's like this. You'll learn it once, and it's fine. Yeah, one thing is to remember that you need to provide you need to implement std error trait for your enum. You can do it manually, but you can do with this error macro, which is very helpful. Yeah, so basically you just don't need to think much about the trait. You just specify what this thing. Yeah, once again, when you're designing your Rust library, you can think about Rust. You don't need to think about other languages or this UDL file. Once you have it, then you can translate, and it will be translated quite natively to the languages you're targeting. So for Kotlin, it would be these methods would be throwing exceptions, not returning result. For Python, also exceptions. Yeah, error handling is done nice. Interface objects, yeah, I think we can skip it. Callback interface, yeah, if you build your library and you not just provide an object to use, but you need some code to be called from your library, so a callback. Then you'll define a trait. Again, it's a Rust native thing, right? It's what you do in Rust. You'll define a trait, and you will ask a user to provide you an implementation of this trait. It should be sent and sync, because on the other platforms it can be switching from kind of from one runtime to another, so it can be sent. It might be sometimes kind of unnecessary on some platforms, but yeah, there's some explanation. One other thing is that yeah, we define this in UDL. We define this trait as a callback interface, and in Rust, yeah, let's say here we want to provide this k-chain interface to this constructor. In Rust, it would be box din. right? Because you cannot parameterize your Rust code at compile time with something in foreign language. It happens at runtime. That's why you need to do this box team. Okay. Yeah, that's how it would be. How it would look in Kotlin. Yeah, again, quite native to this language. The same for Swift. Yeah, here's like option, right? They have similar syntax with question mark, so quite native to the language. That's cool. Okay, so there's some details, external types. Yeah, those are like details which you may learn yourself when you need them, but in general, that's the idea. Now I wanted to show you why, maybe I have to start with why I'm talking about this. Yeah, examples. As I said at the beginning, that if we want to be like cross-platform library, we wrote it in Rust, and we want Android developers and iOS users to consume it, we unify is a way to do this. And as you can see, different projects actually employed it, and it seems it's becoming a standard, basically. And it's also nice that kind of once you learn it, you can use it. And even for application developers also, if, for example, they use a BDK library to build a wallet for Android, then they want to use LDK, they don't need to learn unifying again. It will be the same UDL, well, not the same, but I mean, it will be a UDL file they're familiar with, just another interface, but the logic is the same. So, and the projects like BDK, LDK node, Breeze SDK, they all provide this unify interface with the UDL definition. Lipo Lightning Live, it's the name stands, it's the library we're developing. We also do this for our mobile application developers. That's a way to provide them the library. Let's have a look, just for fun, what BDK defines. So the first namespace, it's empty, but it's the requirement. Yep, they define BDK error. You can see it's the enum, and it's pretty much one-to-one what they define in Rust. Yeah, if it's a struct, address info, it would be a dictionary, right? Keychain kind, okay, that's fine. Yeah, another enum with some values inside, so right, so we can guess from the Rust code. Network, dictionary, anything more interesting? Again, enum, dictionary. Let's have a look at the LDK node. It's smaller. LDK node. Yeah, we'll not talk about BDK, but about LDK. Yeah, like for example, interface, right? You can build your node. No, it's a builder. Okay, to build your node, it's an interface with constructor, setting some configurations, and then build will return you this interface, LDK node. Until LDK node, you can call this method. The next event will return, as you can see, option. So that's pretty much how it looks. Yeah, the errors they have, build error. Yeah. So that's about the UDL file. As you can see, it's pretty natural. So you can start reading it after you just learn it just 15 minutes ago, and you can already read it. Of course, to write it, you'll need a bit more time, but but you'll get it. And the last thing is limitations. Yeah, as any tool, it has some limitations. And one limitation is that you cannot define an async interface. So all interfaces, you can define in your UDL file, they are all synchronous. So you call the function and you wait for the result. It cannot be async. We haven't talked about async, but yeah. And another problem is that kind of what we faced, the question where we put the documentation for the library. If we put it into Rust code, then the UDL would not have this documentation, and the consumers of our library, they will need to read Rust documentation, which is a bit strange. If they're like iOS developer, they're familiar with Swift, maybe they can learn UDL, but they'll need to read Rust, not read Rust code, but at least the definitions in order to understand. And some syntaxes may be a bit not that easy to understand for people not that familiar with Rust. Yeah, we can put it to UDL file, but then our Rust code doesn't have documentation. And if the consumer wants to use the Rust library directly, they need to go to the UDL file and read it there.
I mean, they have to know UDL. They have to know UDL. So, of course,
not necessary. You're building your application on Rust, and you want to use BDK and LDK. You can use them, and it's better for you to use Rust native libraries.
Yeah, but if I'm a Swift developer, I need to know UDL.
Swift, yes.
Yeah, that's what I meant.
But the opposite.
Yeah,
yes, the opposite problem. Yeah.
Both sides have to know UDL.
No, sorry. The second, yeah, I agree with what you said. Yeah. You're right. But let's say I put into the UDL file all documentation, and then I want to also distribute my library as a Rust library.
Yeah, then the other Rust developers will not have a reference.
Sorry?
The other Rust developers,
yes,
they cannot read the Rust documentation because it doesn't exist.
Yes, yes. But why would they know UDL? That's not.
Yeah, because it's not very.
Yeah. You can know Rust, but you never heard about UDL because Unify and all this stuff. Sorry?
What about a parser? Isn't somebody trying to implement like a parser that parses the Rust code and puts the documentation in the file?
That's the idea, yes. But it's for Unify, right? That's since they generate it. Well, they don't generate. So 1 second. The idea. What was the idea? The idea is that that actually you even don't write UDL file. The idea is that you attribute your Rust code, kind of, yes, and then they will be able to generate UDL. But then you will would not need UDL. You would need language bindings, and you can put also documentation there. Then the consumer your library will just see Swift code with documentation. It would be nice, but it's not there yet. Yeah. Yeah. Another limitation is kind of that it just generates you these bindings, but it would not package. It would not build a package for this language. But it's a completely different story. So it's maybe not that really a limitation. Yep. So that's it. We're almost perfect on time. Any questions? Great. Then let's have lunch. And after lunch, we'll do some coding.